right, we want to compute the limit as x approaches 1 of x cubed minus 1 over x minus 1. So the first thing that we always do when we evaluate limits is we plug in whatever value we are approaching and see if we immediately come to an answer. So this is evaluating a limit via direct evaluation. So if we plug in 1 to the numerator, we're going to get 1 cubed minus 1. In the denominator, we will have 1 minus 1. And we will get 0 over 0. This is an indeterminate form, okay? And because this is an indeterminate form, we need to do more work in order to figure out what our answer is. Now, luckily for us, x cubed minus 1 can be factored. So if I do a little scratch work on the side, x cubed minus 1 is the same thing as x minus 1 times x squared plus x and then plus 1. We can check our work, right? Make sure that if we expand x minus 1 times x squared plus x plus 1, we get back x cubed minus 1. So let me pull out the laser tool. So x times x squared gives me x cubed, so we get that back. Negative 1 times 1 gives me negative 1. So what I need to make sure is that all the other terms collapse and disappear. I have x times x, which gives me x squared. I have negative 1 times x squared, which gives me negative x squared, so those pieces will disappear. I have x times 1, which gives me positive x, and then I have negative 1 times x, which gives me negative x, so the x's will disappear. So this indeed holds, all right? If you are unable to come to this via factoring, okay, or just knowing that x cubed minus 1 splits into x minus 1 times x squared plus x plus 1, what you can do is you can do some long division, polynomial long division or synthetic division, and see that your quotient will be x squared plus x plus 1 with the remainder of 0. Now, this will help us because the limit as x approaches 1 of x cubed minus 1 over x minus 1 will equal the limit as x approaches 1 of x minus 1 times x squared plus x plus 1, all divided by x minus 1. This allows us to cancel the factors of x minus 1. This is allowable because we are seeing what happens as we approach 1, so we don't have to worry about dividing by 0. This will equal the limit as x approaches 1 of x squared plus x plus 1. And because this expression here is a sum, we need to make sure that we have some parentheses, okay? If we don't, then we would just be looking at the limit as x approaches 1 of x squared, and then we would have some extra pieces, mainly x plus 1. So now we're going to plug 1 into the function and see what happens. So we're going to get 1 squared plus 1, which is 3, and that would be our answer.